financial mathematics. So at some point, you can probably have to borrow money or invest money. So we're going to go over some vocab here. So the person that's lending money is called a lender, right? The person that's taking the money is called a borrower. Here's the key part. The amount borrowed is called the principal. So you see that a lot. Principal is just how much what's your deposit, how much you borrow, all that good stuff. They usually charge, if it's the person lending the money, usually charge you a fee. It's called interest. And then the interest rate, how much they charge per thing. Now we're going to first talk about compound interest. So this is like you put your money in your bank for a certain amount of time, and the bank pays you a little bit of interest for that amount. Now, when they actually calculate how much they're going to pay that interest, how much they're going to give you a little bonus, it's called a pay period. So it's like, oh, we're going to do it every 3 months, every year. So we're going to pay you that interest. Now, if we do it every 3 months, right, so we paid interest on the first $100, now you have more money in the bank because you just got paid your interest. And when we do it the next time, you're going to get even more money because now our money is like, it's like that's why they call it compounded. Because you're getting paid more and more money based on the more interest you're gaining each time. So the money just keeps compounding for you. So here's the formula. So the key thing here is this is a form from the formula sheet. So this is what IB gives you to do these type of problems. FV is future value, so that's like the money you expect to get after you've done depositing your amount. PV is the present value, also known as principal. So present value is like what you deposit, how much money you have right now. K is the number of times compounded per year. So if you're compounding it twice per year, it's 2, once per year is 1, yada yada. And then R you have to watch out for. Full disclosure, I was halfway through this video and I was like, wait, something's not working. And it's because I have my R wrong. Now notice I said R percent is a nominal amount. So in this case, if they tell you it's like 0.03%, your R is just 3. So we're just using like the value here. So what the percent is. That's why it's R percent. So you're just going to use that value. And then that's what the formula is. So let's do an example. So this first one here, $5,000 is invested for 4 years at 7% interest compounded annually. So what will the amount be? What will the amount be at the end of this period? So a couple things here, right? Years, that's N in our formula. Compounded annually, that means our K is 1. That's how many times we're compounding per year is 1 time. Our present value is $5,000, that's how much we're going to deposit. And our R is going to be 7. Right? Not 7%, just 7. So the percent's already taken into account in this formula. So just put the 7 down. So A, we're just going to type in our formula. So let me write down the formula first so we all know what we're doing. So KN, and I'm going to plug everything in. So our future value is going to be 5,000, 1 plus 7 over 100 times 1 till 1 times 4. Right? So that's everything is. It's an application problem, so we're going to use our calculator. So we get 5,000 times 1 plus 7 divided by 100, all to the 4 power. And we get $6,553.98. There is money, so we're putting the cents. So we made about 1,500 after 4 years. That's nice. B is how much interest has been earned. So if you want to find the interest earned, it's a very simple formula. It's just future value minus present value. So we now have $6,553.98. Subtract off what we deposited, $5,000, and we get $1,553.98. So we made about $1,500. Not bad, 4 years. Not bad at all. Next one, pounds. Ooh, 5,000 pounds is invested for 4 years at 3% PA interest compounded quarterly. Compounded quarterly means we're doing it 4 times a year. So K equals 4 in this scenario. Find the value of interest at the end of this period. So my N is 4, my years. My R is 3. And then my present value is 5. So plugging into the formula, future value equals present value 5,000 times 1 plus R, which is 3, over 100 times K, so 4, to the Kn, which is 4 times 4. So if I just want to make it a little nicer, 5,000, 1 plus 3 over 400, to the 16. Now again, we're just going to put that into our calculator, so that'll be the last time. So 5,000 times 1 plus, now I'll show you a nice way to put a fraction. If you press alpha y equals, and your calculator updated, it brings up that screen. That first one lets you put a fraction down like you see it. So in this case, it doesn't really matter because that's a basic one. But if you did a little more If you start from here, I would have done this, so you make sure you get the right answer. All to the 16th power. And we get about 5,600. So my future value, in this case, about $5,634.96. So we made about $600 in those 4 years. Next one. How much does Ivana need to invest now to get a maturing value of $10,000 in 4 years' time, given an interest of 8% compounded twice annually? Give your answer nearest dollar. So the nearest dollar, we're going to round it. So compounded twice annually means our K is 2 this time. Our R is 8. This is our future value, right? We're trying to figure out how much we need to deposit right now. So we actually don't know the present value. But our future values, we want to make $10,000. And then 4 years' time, that's our N. So let me put that on the formula again in case we forgot it. Again, it is an informal sheet, so you do get to use it. 100K to the NK. Right, so in this case, I'm looking for present value, so it's a little different. So let's plug in what we know. So future value is 1,000. Present value, I don't know. 1 plus R, which is 8 over 100 times 4. Sorry, 2 compounded twice semi-annually. And then all to the NK, so 4 times 2. So there we go. Now in this case, I'm looking for PV. So actually, let me simplify this to make it a little easier to see. So present value equals 1 plus 8 over 200 to the 8. So now look what's going on with this one. I'm looking for the present value, but this is all just a number. So just like we just went like this earlier. I don't have a variable. I don't have a exponent to solve. So I'm just going to divide by both of these things to get my present value. So present value times this mess equals 1,000, 10,000. Sorry, I'm going to shortchange her. So 10,000. So I'm just going to divide both sides by this. That'll give my present value. So we're doing the opposite. And so my present value is going to be, so type that all into my calculator. So that's going to be 10,000 divided by 1 plus 8 divided by 200 to the 8th power. We get 7,306. Now to the nearest dollar, so 7,307. She needs to deposit $7,307 right now. So then 4 years time at this rate, she'll get 10 grand. So she makes about 3 grand in 4 years. Not bad. Inflation. Inflation in general is just the price of goods, the increase in price of goods or services over time. So prices in general rise as time goes on. So what that does is it reduces your purchasing power. Because if your money's just, like you just have your money saved, that's just staying. It's not really increasing. So your purchasing power goes down as inflation goes up. So inflation needs to be taken into account when setting investment goals. For example, suppose you see a painting that you like to buy that costs $5,000. Okay. It takes 3 years to accumulate the $5,000. The price of the painting is likely to have increased in that time. So it's not gonna be like, right now it's $5,000. But when you actually plan to buy it, you have enough money to buy it, it probably won't be worth $5,000 at that time. So you have to take into account inflation. So all you have to do is index it. So let's explain what I mean in a second here. Georgia would like to purchase a painting that's currently worth $5,000. She makes monthly deposits into an investment account so that she can purchase a painting in 3 years' time. If inflation averages 2.5% per year, calculate the value of the painting index for inflation for 3 years. So all that is like how much has that price increased? This is a growth equation. That's all that's going on. The price of the paintings is growing by inflation. So we're gonna do the exact same thing we did before, where we go our initial value, which is U0 times our growth rate times N. Right, where N is time. Now my initial value is $5,000. Our growth rate is right here. Now remember, you have to add, our R is always 100 plus or minus that, or 1 plus or minus that. 100 plus 2.5, which is 102.5 or 1.025, right? When we plug it into here, unlike the other formula, we plugged in as a percentage. So 2.025 plus 1. So that goes in here. And then we're doing 3 years. So what's inflation going to be in 3 years? When I plug that into my calculator, we're going to get $5,384.45. So that's how much the paint's worth in 3 years. If it's going to stay at the same price, same value, but going up with inflation. An industrial dishwasher purchased for $2,400 for $2,400 and depreciate by 15% per year. So this one's going down because we're using it, so it's going down in value. So it's the exact same formula. We're going to use UN equals U0 minus amount, R to N formula here. Now in this case, our value is going down, so our R is actually going to be 1 minus the amount. Find the value for 6 years. So the first one here. So let's find out our R is, right? So we have 100%, and we're subtracting off 15% because it's gone down in value. So we get 85%, also known as 0.85. So that's our R. So my formula for after 6 years is going to be U6 is going to be my initial amount, 2,400 pounds, times 0.85 to 6. So after 6 years, get 24. We bought this thing for $2,400. Now we're times it. It's going down by 15% each year for 6 years. So now it's only worth $900 and $905.15, 16 cents. Oh, pounds. So there we go. That's how much it's worth in 6 years. But by how much did it depreciate? Well, if you want to find how much it depreciates, just do your present value minus your future value. Right? Type of thing. Like how much should I pay for it? How much it's worth now. So you just subtract those two. And that'll be 1494.84. Right, so I get that. So it went down about $1,500 or pounds. And again, it's because this one depreciates. It's a loss of value. When something depreciates, we lose value. Lose our loss of value over time. So there we go.